over here is 33 only. Who still did not scan your attendance?
Yes, Doctor.
These are Kirin.
I tell you about I can't download the UTM Smart. Yes, remember me from Libya.
I already asked the person in charge, but there is no response yet. So maybe I will try to ask them again. Because this is really rare case. Because I think none of us facing that. Maybe only in your country. UTM Smart cannot use.
Yes, I can't use. Country.
But it's okay because I already noted, right?
Okay.
And I already asked the PIC regarding these issues. Ahmad Ahmad apa yang namanya? Yang menyanyi hari tu ketawa. Okay. So last class. Okay, the last person coming in our class today is D Zakirin. So please take note, D Zakirin. Anything you need to be prepared.
Doctor, that was my second device because I entered using phone first and then I entered using my main device later.
Pandai bagi excuse. Okay. I already also, let me check. Who's the late person? This one. Let me open. Ting Shing Ho and Ariful Islam. Ariful Islam is international student. Ting Sing Ho, I guess it is Malaysian, right? So both of you. Now.
Hello, doctor.
Let's.
Doctor.
Yes.
Do I have to scan again the QR code? Because
what happened?
I already scanned it before 1 hour.
It's okay, only one time. So it will already scan your names over there.
Okay.
Okay. So in our previous class, we still did not yet finish the module 1, right? But we nearly to finish, only another one last point, which is an example and system. So I ask all of you to go through about the example, and later on I will also look into it because it's quite also large in numbers. I try to finish it by today. Where is it? Starting from here. So we already look into the hierarchicals on the levels, machines, and then what else we look? The virtual machines, layers in our previous class. So if you didn't remember, you can just go through back all the videos that I provided in the e-learning, which is linked to the YouTube. And today we're going to start on our example. So for the examples only is already occupied more than, I think, 20 slide. No, it's 19 slide altogether. I guess you can see that everything over here. Let me share the screen. I'm not sharing the screen, right? Let me share my screen first. Okay, now can you see?
Yes, sir.
Okay. So this one we also already touched a little bit last class. So over here, this is how if let's say you want to sell the computer or your laptop, you're going to do like these flyers, the advertisements. So if let's say you want to buy, also you can see that there is advertisement like mentions about what Pentium, what is your, how many ports that available, what else, the sound card, the graphic card, and etc. So that's why you need to learn this computer architecture and organizations subject. So over here it mentions what all this means. L1, what is the keychains, what is PCI, what is the megahertz, what is USB. If you don't know, then it's hard for you to pick which is the correct computer and also the correct laptop for you to use. And this is all the mathematical measurement terminology. I'm not going to teach you because this one you already learned in your secondary school, I guess, about the kilo, the mega, giga, tera, peta. I guess it's until tera, but now you can see there is also peta because I also just me with this, and then milli, micro, nano, pico. I guess in your secondary school you are learning until over here part, but now you have learned the peta and also femto. So you need to see about the representation. It means that if 1 kilo, it means that it is thousand. If mega, it is a million. If giga, it is billion. Tera is trillion, and etc. So if you don't know about this, it's hard for you to deal in any kind of mathematical form. So please make sure you memorize what unit represent to what numbering system. What else? Okay, so there is also examples on the hertz, on the byte, uh, the capacity and also speed. So if you look into the advertisement back, you can see that there is a part of hertz. So what is it representing? Which is about your frequency, the processor speed. So the higher the processor speed, which is your hertz in the advertisement, so the higher performance of your computer. So that's why you need to check the hertz. So I go back to the advertisement. Where is it, the hertz? It's not mentioned here. Okay, this one. So you can see this is the frequency of your processor. Then what else? The byte, the unit storage. So how many storage that supported maybe your secondary and also your primary storage. You need to look into, which is for your main memory is called as a RAM, and it's measured in megabyte. So you can see also in the advertisements that it will be having the RAM. So the disk storage is measured in gigabytes for small system, terabyte for the large system. So normally I guess now we have up to terabyte normally in our computer and also laptop. But for laptop, I guess only gigabyte. And there is also on a millisecond on your hard disk drive. So you need to check it nanosecond, which is time and also space. So over here, the micro, which is my 1 million of meter circuit of your computer chips are measured in micron. So if you look into the advertisement, there is a micron, you will see, oh, I know now, this is about my circuit computer chips. So that's why you need to learn on your COA subject. So note that cycle time is on a clock frequency. So you can also convert from hertz and then to the cycle time. How you're going to convert later on, you will learn it. I guess also last semester you already learned on your digital logic, which is you playing around with your numbering system, right? You need to learn on the numbering conversions. Although it's quite simple and it's not too deep, but still you have the basic knowledge on that. this is the example of the advertisement, the similar advertisements. I guess that's not too hard for you to understand because you are dealing with a computer and laptop every single day, right? So memory. Normally in a RAM, which is random access memory, there is also a ROM. Wait, kita iklan sekejap. Ariful Islam, what is the meaning of ROM? Where is him?
Yeah, Dr. Okay,
What?
ROM actually read only memory.
What again?
Read only memory, right? Read only memory.
Yes, good. Thank you for your answer. So we continue our class. Because over here I just stated about the RAM, so I just want to know whether you already read and go through the notes or not on the RAM and the ROM. Maybe it also not stated here, but this is your own knowledge because you are dealing with the computer and your laptop every single day, right? That's why you need to have that knowledge. And then on the caches, you need to know that it is type of temporary memory. Sometimes there is a lot of cache in your memory system, so it will be also burden your RAM. So this is the example of advertisements also. So it's stated that there is a level 1 and level 2. What is this? So note that these all size are measured in kilobyte. So maybe you can be given the question that you need to create the advertisement by your own. So also maybe you can also been given a question to fill in the blank. So that's why you need to know what measurement type for all this. Let's say for frequency, you need to fill it blank. What is this? Oh, so you know that frequency is megahertz. And then for your storage, that you need to know what is, maybe it is a gigabyte. Similar to your sound card, what is the measurements and so on. So this one is on your hard disk, which is on your storage. Still related to your RAM. And you can see also about USB. Normally you only know about USB. But what is USB? Now you know that it is universal serial bus. Who didn't know about this term? Who just know oh, I got USB. Yeah, I got USB. So what is basically USB stand for? So this is the USB term. Basically, it is a universal serial bus. So in the short form, you call it as USB. Okay, normally these all port available in computer. If you are not dealing with computer, it's hard for you to check all of these port. So in computer, there is a serial port. Sometimes you might confuse because it's look like similar. So you need to know that this is the front, this is the back, and what is the connections to it, female, male, and then also about the parallel port. So normally it's also quite similar, but the number of pin available is different. So you need to differentiate what is serial port, which one is the parallel port. This one I guess you already know because normally you always use the USB port to use in your every devices, your microphone, your USB, what else? Your mouse. I guess all of
Keyboard.
keyboard, yeah. But sometimes also you have the wireless keyboard, but still you need to use the USB, right, to plug in.
Yes.
And nowadays, if you are using um, MacBooks, you will see that you are not using USB anymore. So you need to have the converter for your female and males, which is because normally USB, current USB are using current mouse is using USB, but your port is using a C type. So that's why you need to have the converter between C and USB. So many others converter also available. Let's say for your laptop, it doesn't support or it does not given the serial port, but you need to use it. Maybe you want to use the point projector, so you need to use your serial port. But your computer, your laptop is not having the serial port, so you need to have the converter between serial port to USB and etc. And you can see also there is a system bus which is input output, and also our PCI parallel component interface. So this one also is very important. If you didn't have, let's say, sound card, so you need to check what you need to do because sometimes it sell in loose packet. So you need to see how bits your card sounds support, what is the voice modem, and for the one that normally doing graphic, doing the video editing, or maybe you want to play a gaming, so this is very important, your graphic card. If you are go for editing for 3D modeling, so you need to have the very good graphic card. So all of it that you need to check before you buy your computer. So I guess that's about our module 1. You can also read and go through it about your monitor, how many refresh rate, the dot pinch, and your resolution, how big the resolution, because the resolution will result in your picture. If you want to play with gaming, so you need to have a high in resolutions, something like that. Same goes to your graphic card. This is the one that I mentioned. So you need to look in back or what you already learned, because basically, as I already mentioned, in our module 2, it's just more to theory. So please make sure that you understand and memorize all the term. Although you cannot memorize it in all the sentences, please make sure that you remember the keywords. Wait. So anything that you want to ask regarding your module 1? Any question? All of you understand? Delay.
Understand, Doctor.
Hello.
Understand maybe now.
Faham.
You still have so many things to remember.
So many things to remember. Yes, I don't like theory. That's why I prefer more to like calculating term, and then not on theory. Okay. I'm going to open our module 2. So we're going to look into our module 2 now. Is it okay? Let me share my screen now. Okay, this is module 2, as I do believe that I still not yet uploaded this module 2 in your e-learning, right? So today I'm going to upload after this class because I want to ask you several questions. The main point is because what I see in our module 2 is basically related to what you already learned, which is have very strong correlations with your digital logic subject. So that's why I want to ask a few questions. So stand by. So this is the objective. On our module 2, you can read it and go through it. And what you're going to see is mostly on numbering. You can see over here. And you already learn numbering in your digital logic. That's why I mentioned that mostly all what they cover in our module 2, which is numbering, that related to your digital logic. So first of all, we're going to look into the arithmetic and logic unit. So what is this? You already look, which is we call it as ALU. So ALU is very important for your computer to, I guess, if you didn't have ALU, your computer cannot be operated. So over here, there is a few questions before you go through because you need to know how negative number represent. What is the last number that can be represented in the computer world? What happens if an operations create a number bigger than can be represented? What about fractions and real number? And the mystery, how does the hardware really multiply and divided numbering? So how basically happen in your computer? So ALU, as you already looked, which is your arithmetic logic unit. So this is one function that very important and like a heart for your computer, which is more to their processes things on your computer. So computer arithmetic is commonly performed two very different types of numbering, which is integer and floating number. After this, you're going to look into the diagram divided between integer and floating point. In both cases, the representation chosen is crucial, design issues and etc. You can read and go through it. And here, so you can see over here, there is two big difference between fixed number, which is integer, and floating point. Normally, you are looking to this fixed number, your integer on the representations, unsigned and signed number. You already learned in digital logic, right? And also, I guess, in your mathematical subject in your secondary school. So a lot of repetition, I guess you can score 100% in those module 2 because this is all repetition from your mathematics subject, from your digital logic. So you're going to have high understanding in this. And then after that, you have the arithmetic. This one, the one that you are performing the addition, subtraction, multiplication, and divisions. And did you remember this one? Unsigned integer and second complement. This is from your digital logic, isn't it? So this is under the fixed number because you already go through it. And now the new things is under floating point. Still, there is two, which is representation and arithmetic, but you can see the difference. Arithmetic only have additions and multiplications. There is no subtraction and divisions. Weird, right? So later on, you will see why. So under the arithmetic, I call it only ALU, okay? So under the ALU, it is a part of computer, you already looks that it is very important which perform the arithmetic and logic operation. Logic operation is the one that tambah tolak darab bahagi, addition, subtractions, multiple and divisions. So you can see over here there is a keyword. Rindu tak dengan perkataan ni? Did you miss digital logic? So it is basically, your computer is basically a combination of electronic components from your simple digital logic. So siapa yang dapat A plus for digital logic, mesti kena dapat COA pun A plus. Okay, for this subject, because it's very simple, right? It is linked to your digital logic subject too. So later on you can see that it will store in binary digit. Binary digit is what? Power of 2, right? You have only 2. I already mentioned by is normally only 2, which is 0 and 1. So you have these 0 and 1 only. So your computer programming normally know only 0, 1, 0, 1. Although you type A, B, C, D, everything that you type mostly will be converted into 0, 1, 0, 1. And then your Boolean logic operation. I guess maybe someone love this Boolean operation. Maybe someone not, because you also need to remember last time, right? There is a few rules that you need to remember if you are playing around with your Boolean expression, Boolean simplifications, but you are not going to do that in this subject. But still, yeah, there is a correlation between Boolean operations with your Boolean logic operation in your COA subject. So you can see over here, fixed number, integer representation, which is overview, and unsigned number and signed number. So now, penat cakap. So, let me pick. Semua buka webcam ni, macam mana ni nak pick ni? Tadilah siapa yang lambat tadi? Forgot the name. Ting Sing Ho. Where is it?
Yes.
Ting Sing Ho. Okay. Because we already learned last time in our digital logic subject about unsigned and signed number. May I ask you how the negative number will represent in the numbering system, whether it represent as 1 or 0 for negative number?
S1?
What's 1?
1.
Okay, so it's correct. So for negative is going to be 1. And for positive is going to be 0. Later on you will go through back. If you did not remember, then you need to take back your digital logic subject. Go back to the slide. Okay. Over here, you're going to see that you are learning the numbering. So for those who already master a numbering system, maybe it's quite boring because, yeah, what you need to learn, because this one you already learn in your secondary school. And then back then, I think there is a lot of other subjects that cover in numbering also, right? In your COA subject, you also need to know, because basically we are dealing with 1010 numbering in our computer language. So it is best to only have 10, which is called as a binary number system. And normally you can see that you have the number. Let's say this one for your binary number is going to be 1, let's say, and you have the power of, let's say, to the power of something over here. This one is your best number. This one is the value. So let's say 1, and then you have the to the power of 0. So you will get what? This one you already learned also in digital logic. Let's say I give you the simple example. We have 7. So this is my favorite number. Let's say you have 7 and you know that this is basically the decimal, which is base 10. So how it's basically happen over here is 7 over here, you know that this is at the power of 0. If let's say over here there is another one, this one is the power of 1, there is another one, or there is 7 here, it is the power of 2 until move power of 3, 4, and etc. So I just pick this 7 because this is my favorite number. 7 times with my best. The best is 10. And the I value is the power of version over here, the value of I, which is 0. So 10 to the power of 0. Any number to the power of 0, 3 to the power of 0, 7 to the power of 0, 6 to the power of 0, everything will be 1. Is it correct? So this is mathematical terms, and also a flow how you're going to convert. Then you get 1 right. 7 times 1, you get 7. So that's why the value is 7. And I give you another example. Let's say in base 2. I have, for base 2, I can only have 0 and 1. So let's say I have 1, 1. Base 2. So this one is 1, 1. This is not 11. This is not 11. Because this is not 11 because it's already stated over here. This is the base 2, which is binary number, right? So 1, 1, base 2, or binary number is not 11. But what happened over here is this is the power of 0, this is the power of 1. I'm going to multiple it. So over here, I start from the right. 1 times 2 the power of 1 plus, because I have another one, 1 times 2 the power of 0. So you can see over here, I got this one. So I use this equation and I apply on here. And this another one, I use the same equation. The different only at here, if you have different value. If 0, then you put 0. If 1, you put 1. And the power of over here is followed by whatever power that moving. And because of this, I got 1 times 2. Because 2 the power of 1 is going to be 2. And 1 times 2 the power of 0, I get 1 times 1. So over here, 2 plus 1, I get 3 to the power of 10, which is decimal. So the value of not 11, 1, 1 binary equal to 3 in decimals. So normally you are using the decimal, right? So this is the value of your binary number. That's why you're going to use these equations in converting any kind of numbering system. So for those who already know, don't feel boring because I just want to refresh your memory how and why you use these equations for your numbering system. So over here, there is also noted that way I, which is I normally use the power of starting from 0, from right. That's why I mentioned it's from what 0, 1, 2, 3 to the left, and 3 until infinity. So this is the note over here about the I value. And this one is on the binary equivalence. This also you already look into it. What is the nipple? What is the byte? Byte converting to the bits. This one have, I guess this already have in your digital logic also. And the rest, I guess, in the mathematical subjects. Everything's already there. So please make sure you remember, and I guess it's easy for you also because you have the technology. You can just convert it using your scientific calculator. See over here, this is the sign extension. This is the one that I asked. I forgot the name again. So this is the one that you need to use the sign extension. If it is 0, it's going to be a positive number. If it is 1, then it will be a negative number. So please don't forget about this because it's repeating several times about this signs number. Is it okay? So this is just example of the sign number. If you have 8 bits binary to the 16-bit binary, how you going to convert it? Let's say you have 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 binary number. Over here it's 0. It means that it is positive. While you convert it into the binary, 16 binary bits, how you going to convert it? Basically, there is no value in front, so you just put it back 0, 0, 0. But if you are dealing with negative number, when you converting it, you cannot put it because everything over here, there is no value, right? Let's say for binary, if 1, 0, the value is will be 2. So in front over here should be 0, 0, 0. But this one is positive number. But if it is negative number, you need to put it as a 1, 1, 1, 1, 1 over here. So that's why this is another example on negative number. You put everything in front as a 1, 1, 1, 1. So over here, this is the only value for 1, 0, but the rest you convert it into 1 as to show this is the negative number. But this one is only for sign extension number. Sometimes you might confuse because maybe you don't know whether this is the sign for negative or positive, or this one is just on the value, right? So it might also confuse. So you can see over here, this is sign bit, and this is the sign bit extension, the one that you need to add. This is the type of numbering flow diagram. You can see that there is a sign, magnitude, and complement. This one you already look into your DL subject. So if you think that the notes under COS subject is not too deep, go back to your digital logic books, your notes previously. I think it's very complete mentions about first complement, second complements, signs number also already cover. So go back and go through back all the notes, and you're going to increase your memory and understandings. So what else? Okay, over here. You also already learned on and MSP. So, what is basically, cepat-cepat Google tu. What is basically LSB? Radin, what is
Yeah.
LSB?
LSB,
Uh,
the rightmost bit.
L.
Least. Yeah.
No, I heard that you mentioned right. But it's
The
also
rightmost.
in the right form, but I want to know the full name. So least, so this one LSB, least signs bits. So you normally find it on the right of your numbering. Where is my pen? Okay, so this over here is your LSP, and over here is your MSP, more sign bit over here. If you have 32 bit long words, you're going to see that you have 31 bits altogether, including the bit 0. That's why altogether you will get 32 bit long. So this is just the example on your unsigned number. So you can see that you have also sign magnitudes. So this one is if you need to represent the value of your negative and also your positive. So that's why you need to have the sign magnitude. So normally you're going to put your sign magnitude on the MSP, which is the leftmost bits in your byte. There is several example later on after I uploaded it. Please try to do the example 1, and then there is also another example 2, example 3, and etc. So it's continuous. So please try to do it. Basically you can don't use your calculator. Please use the binary form and try to do it. As long as you understand, I guess it's very easy. And we also already go through in our digitalology subjects. There is also a lot of example there in our notes. So this one is adding 79 to 39 using sign magnitude. So there is also a hint over here using 8-bit binary. So that's why you can see 1, 2, 3, 4, 5, 6, 7. After that, your MSB, isn't it? The most sign bits over here, you're going to represent it with your sign, whether it is a positive and also whether it is a negative. So please try to do it. And you can see that the sum of two positive numbers, which is positive. Overflow is a sign numbers occur when the signs of the number is incorrect. So please make sure that if let's say you have the overflow, you're going to check whether there is an error n or not. The sign bit is used only for sign so that we can't carry into it. Otherwise, the result will be like an error, especially for your MSP bit overflow. So it's going to be given incorrect in your answer. So there is also another example. You can go through it. This one, another example too. This is also in a sign magnitude. Still adding. You not yet cover the subtractions. I guess adding is quite simple because you are not looking on your first complement, second complement yet. This one is quite similar with previous example 1. But over here you can see that it gives you error result. So why it's happened? So last carry overflow and is discharge. So maybe over here you can see that normally you have 1 1, you're going to have 0 1, isn't it? So you bring it over here. So this is basically the overflow and it is normally discharge. So if let's say you add it, so it's going to be error in your result because you're going to have the positive number, not negative. Similar to example 3, please try to do it, and if let's say you think that you did not understand, please refer back to your digital notes. If you still have a problem with this example, all the example given, please contact me so that I can assist you. So we can conclude in sign magnitude that we have first problem that if any carry emitted from the last bit, the result will be truncated as the last bit overflow, giving in incorrect sum. Same goes to what happened in your example 2. And another conclusion that complicated to define the larger magnitude to subtract negative number. Borrow from, okay, this one in subtracted, there is no yet examples on subtractions, but later on you will look into it. So this is two big problem in science magnitude numbering. Then now we go into our complements. First complement, second complement, and etc. This one you already learned and cover, but so we just go through it. In complement system, negative value are represented by different between numbers and it base. So on the base system also we will represent it. So a negative value is given by different between the absolute value number and also one less in bit. And you can read all of this, but the most important is the amount to the little more than flipping the bits of binary number. This is under first complements, the binary system that give you first complement. This is the example when you are using first complement or ones complements, which is at bit binary arithmetic. Suruh Firas makan, nak pukul 1 lah. Dah. So the last over here, this is the last carry 0 after you add here. I guess 1, then 1. You can try to add it. And basically, if you add it, you're going to have negative value on for your number. But how it's going to be like this, which is 0. So this is the last carry, which is 0. So we have done it. And basically, this is the first complement of the negative 23. So you're going to convert first your negative 23 to be in terms of the first complement number. So you're going to convert and you will put it over here. So you're not going to directly convert 23 negative. Directly you convert to the binary. But you're going to convert it to the first complement first, then you will do the adding process. So this one is the one that we already learned in our digital logic, which is we are using additional summations for different kind of magnitude, whether positive and negative. So please try to do this example and look how you're going to understand both sign number. There is also example 5. I'm not going to touch until second complement because I want to share with all of you back what we already cover in our DL subject for first complement, because the notes and also what we already cover in first complement, second complement numbering system in DL subject is much more deeper rather than in our COA, because this one is just a go through. So I don't want you to lose rather after this, because you're going to play around with adding, with subtractions, all the numbering system. So you need to have the foundation and strong in your basic. So after this, I will share the notes first, and please go through in your e-learning, read the notes that I'm going to provide, and I will share a video also, which ones on the first complement, second complements, related to your DL subject. So you're going to refresh back your memory in numbering system. Is it okay? I will put it and share it in your e-learning.
It's 13
the
hours.
video is going to connect it to your YouTube. So any other question?
It's fine, doctor. Thank you.
Okay, if there is no question, please make sure you already scan your QR code, your attendance. And don't forget to go through back, and I will share the video after this in your e-learning.
Okay, sure.
Meet you again tomorrow. We're going to start at 9 a.m. tomorrow. Okay, bye-bye.
Thank you, doctor.
Thank you, Dokter.
Thank you, Dokter.
Siapa tu Semangat betul.
Thank you, doktor.
Bukan itu doktor.
So,
It's Muiz.
madam, it's like
Dia
that
semangat nak
class
nyanyi.
like
Dia semangat nak nyanyi
today.
lagi. Muka tak pernah tunjuk tu.
So, madam, the class is like always, the today class is start at 12 and the tomorrow class is start at 9.
Yeah. Because normally I'm not going to cover 2 hours in one class. You're going to occupy your internet quota very high. And basically, if you are from my DL subject, mostly I will provide 1 hour video before the class session. But today I'm not doing that. So sorry. Lim? Lim here?
Yeah.
Okay.
So,
So
like start at the last 1 hour minute. Start at the last 1 hour lah.
Okay, normally if we have 2 hours class, right? I'm
Yeah.
going to give you 1 hour video first. So you need to watch it before our class. So in class, basically we're going to discuss and continue what happened in the video.
Okay.
Only for today, I guess I didn't give you any video, right? Similar to previous class, if you look that I provide with the video 1 hour, and then we have a class after that, right?
Yeah.
Dia kata.
Okay. Thank you, Dokter.
Okay.
Thank you, doctor.
Okay. Bye.
Thank you, doctor.
Thank you, doktor.
Okay, bye-bye.
Thank you, doctor.